So let's talk about the dynamics of positive estuaries. Okay? So essentially, the density structure in estuaries, in positive estuaries, is controlled by the salinity. You have a low salinity top layer sitting above a higher salinity bottom layer. Okay? And what creates an outflow of low salinity water into the ocean is what we call a barotropic pressure gradient, a pressure gradient towards the ocean. Okay, and in this case, the Coriolis force does not become dominant because you have a narrow system, and this pressure gradient just pushes the water down the slope towards the ocean. Okay, and this is the one part of the force. And this explains why you have a flow of low salinity water towards the ocean. However, you have another force which is related to the horizontal density difference, and it actually creates something we call the baroclinic pressure gradient. It actually moves seawater into the estuary in the lower layer. Okay, you can see the inflow. So these outflows and inflows set up the salinity structure, which becomes modified through mixing. And the mixing is mainly associated with the tidal flows. Tidal currents are currents that move in and out, that move water in and out of an estuary, and via the interaction with the seafloor create turbulence, and they mix, okay, to some extent, partially mix the surface and the bottom layers. Okay, so this combination of forces and the degree of tidal mixing now creates specific salinity structures, salinity environments. So there are two competing factors actually. There's the flow of low salinity water, fresh water, from the river actually wants to establish density stratification, salinity stratification. And the tidal currents through turbulence actually want to destroy the density stratification. And this is what we express as the R/V ratio. All right.